actually, those four objects are a package. They host some functions, multiple functions that you can use to simulate these requests and do the assertions and validation things that you need for you to test your endpoints. And I think looking at the code that we have for that character controller that I was telling you guys about, so one thing we saw was the WebMVC test, which explained plugs in a version of the web application context that, you know, the web application context allows us to host the objects that we need to simulate and process and simulate the processing of those HTTP requests. So just from its docs, saying it's an annotation that can be used for a Spring MVC test that focuses only on Spring MVC components. So this will bring in the components that we need, the services, the repositories, anything marked with that component, and and some things within the framework like the filters, the handler method resolvers. I remember those handler methods that we talked about, the get mapping, put mapping, post mapping. So that handler method resolver is also plugged into the test so that we can use it to simulate the tests. So that, you know, in a way, we can also test if somebody does a post request on an endpoint that will be defined for a get request. At least we can catch that, we can handle that within the test. So that, you know, you validate that you've actually programmed your endpoints correctly. Yeah, so let's look at, so there's a few things that are done within this code. So with the MVC test, we are specifying the controller that we will be testing, we'll be using for this test. So that creates the context that this test is specifically for that controller. Of course, I see that David added the API URL. So this is the request mapping. This handout takes care of the request mapping thing that we handed here. So that also for the test, we strictly put it within the / character context. Of course, he added a show character instance. So this is test data. So yeah, so that's test data that we'll be using for the requests. Personally, I actually like having the test data within the specific test method, but it's no problem if it's a global variable. I think we'll talk to David later to see why he made this a global variable. Otherwise, I would try and restrict it to the test function. So the other thing I'm saying here is the DTO. So this is the resource. This is the type of data that we'll be sending to those API endpoints or receiving back from those API endpoints. And there's this variable request, which is a misnaming because it's actually a serialized version of character DTO. So David, you missed some naming conventions here, but we'll discuss them. I will discuss them a bit more. Okay. So we are seeing object mapper. So object mapper is a serialization deserialization library within Java. So it can allow you to convert Java objects into JSON, JSON into actual objects that map your Java code, your Java defined resources. So for instance, this character DTO, if we wanted a JSON representation of a JSON object that has the name, description, and status, we would use the object mapper to create that JSON representation. Actually, I think that's something we can demonstrate quickly. I'll just write a simple fake test here. We call this Jackson test. And I think we talked about this briefly sometime back. But let me just demonstrate what that object mapper does. So serialize character. So let's say we have a character, show character. We should have an instance in data dump, so I don't have to create a new one. Or let me just create a new one. It doesn't have too many properties. In this case, I'll use the DTO. DTO character DTO. the DTO expects, okay, this is, okay, and this will take a while to use as demonstrated. Let me just use show character for that. So this one takes ID, name, description, status. So let's say the ID is 1L, 1 long, then there's the ID, then I think the name, so the name is Rick, description, maybe it's main character, as Rick is the main character, and then the last argument is the status, so dead in this case, or okay, dead. Let me use that. So if you wanted to convert this into JSON, we can use object mapper, and then we can straight up say JSON is equals to show character equals to new object mapper. Just like you saw David use it, you can say write value as string, and then we pass in the object that we want to convert to JSON. So this allows us to programmatically create our own JSON strings to use for our requests, because the client will be sending us JSON. So when you're writing your test, you also need to create the JSON string and use that as the payload. Yeah, so then once we have the JSON string, maybe I can try and log it. I'll use the self4j logger, so I can say log.debug and say show character, use the new line there, and then print the JSON. So if we print that, okay, my logger didn't work. I'll use this out. Just plug that in. Okay, so then we have, you see now we have the JSON representation of the show character. I still have the same properties, Rick, main character, dead, but now they're represented as JSON. So you need that for you to do the HTTP request to the endpoint that will expect you to give it JSON. So that's why we have it for the controller test. So I'll just go ahead and delete this. It will, later on it won't make sense in the context of the code base, so that's why I'm deleting it. So that's why we need this object mapper. It's essentially for converting the character DTO into a JSON representation. So this request is not really a request. If David can allow me, I think I'll just go ahead and rename it to maybe request payload or request body. I usually use the word payload, but you can use request body for this. And we get more creative, request body JSON. Okay, so anytime you see request body JSON, just know it's the character DTO, the one that was obtained from datagram. So the datagram just has this character that we'll reuse for the test. ID 1L, Rick Sanchez, that, and then alive. Something interesting here is we have this before each that annotates the setup method. So before each basically means the function will be, this function will be called before each test. So before should create new character test is executed, this before each function will be called. And that's why it's labeled setup, because it will be creating a show character, creating the DTO, creating the JSON representation before the test can execute. And you can see the test itself will be using some of those objects. So this creates those objects before they end up being used. So before I go to the specific test methods, there are a few other objects that are added here. So you'll see we have character management service, and we have the MockMVC. So the character management service is added using this annotation at mockpin. So if you guys are familiar with mocking, so mocking just allows us to create empty versions of the objects that would otherwise you use in the production code. So with with a mocked object, it means some of the objects and functionality that's available within that object won't be available in the test. I think the best way to look at it is if the object has a specialized function, like in this case we have that character management service has this function save character. When this is a mocked bin, this detail is removed. So some of that detail is not available. So then you can say whenever this empty character management service is called with a character DTO, just return a show character, and you can define how that show character will be will look like, so that this code won't be executed in the process, and that saves you the stress of actually worrying about this call to the database, because this character repository that exists by name is actually going to check the database for whether this character with the specified name exists. So when you mock the bin, you strip out some of that functionality, and that gives you an opportunity to simulate the functionality, and we'll see how you do that simulation. Then we have auto-wired. So I think we've discussed auto-wired is just injecting this object. And the same way we discussed, you can do field injection or annotation-based injection. We can even get rid of this auto-wired, and within our setup function, we can create a MockMVC object, MockMVC, and you can say that MockMVC is equals to a specific way of initializing. I think I also removed that annotation deliberately because I wanted us to look at those objects that I referenced earlier. So in the setup stage, setup choices, I referred to so in the setup stage, I referred to the MockMVC builders. So these MockMVC builders allow us to actually create a MockMVC instance, and the way we would go about it is you can say MockMVC builder MockMVC builders so you can do a web app context setup, or you can do a standalone setup. A standalone setup is good because if you have it removes the other aspect of your API, other Spring WebMVC setup that would make it difficult to execute your tests. So one example of that is security. So if you have security setup for your endpoints, when you're simulating the HTTP request, Spring will want you to pass in credentials and basically make a request that would qualify to pass through your security layers within your API endpoints. So if you do a standalone setup, it actually strips out that need for passing in credentials when you're simulating HTTP requests. So you can just do a HTTP request without passing in credentials or anything, and you're testing an endpoint that's actually supposed to be secured. So that's why I usually go with standalone setup, but basically just demonstrating the setup process. So the thing that you pass in here is the controller. So you need to pass in an instance of the show controller, which in this case we can use at auto-wired to plug in. I'm modifying an already existing test, so I'll remove my changes after this, but just demonstrate multiple ways in which you can approach this. So you can have a show character, and you can plug that in here, show character controller, and then you can call build. So after that, you'll have a valid MockMVC test that's specifically created for the show character controller, and because it's a standalone MockMVC, it strips out the other setup that you have within your API, like the security aspect that I talked about. So if you have somebody needs to pass in like a JSON web token for them to access the endpoint, when you do a standalone setup, that need is removed. So your test functions will need to pass in a JSON web token. So I just plugged this in to highlight the first object that we looked at in the MockMVC documentation. So I'll just go back to the way David had structured this. So we just have auto-wired. So the auto-add method will automatically plug in the default version of the MockMVC, so you don't have to call MockMVC build as our standalone web application context setup for you to like create an instance of MockMVC. So this kind of plugs in one from the test web application context within Spring. And the way that's provided is through this WebMVC test annotation. Okay, so we've looked at the two bins. So this brings the character management service, and the reason why we are bringing character management service is because the control actually depends on it. The control actually depends on it to execute pretty much all of its functions. So if you want to simulate this, we'll need some sort of reference to that character management service. And we are calling MockBin because we want a simulated version of it, not one with all the other dependencies and related functionality. Okay, I've explained a few things about how this test is set up. Just in case I missed something, or just in case David wanted to explain something about how we approached it. David, I think I'll give you a chance to explain anything that I might have missed up, or any inspiration that you might have had in setting up that MockMVC test, if you don't mind. And also if you're still there. I know it's late now.
So I think your explanations were quite clear. So the only thing I wanted to insist on is that for me, the reasons that I was actually making the show character global was because these are so many tests that I did not want to repeat the constructing the same character object whenever I'm testing. So that was the only reason. Otherwise, you could have just done like you are saying, where you do it to a particular test, for every test you make a character or something of the sort. But since I was taking each test as its own, that's why I'm even doing the before each test. So I'll be making the character assuming that it's the only test I'm doing. It's not related to any other test. That's why I'll be doing before each. I use the global character instead of instantiating that character on every test. Those are my inspirations. Also, I forgot about the naming convention. Thank you so much for that.
Yeah.
Otherwise, the rest of the setup you have explained really well.
Okay, thanks, David. But I'm inclined to agree with you. I think in a way, yeah, in a way, it would be good to have the show character as a global variable. I think I usually end up doing that because for me, the endpoints end up having different needs. So maybe one endpoint will deal with one instance of show character, maybe one will want a list of show characters, or maybe just end up processing some other extended resource. But I agree with you. I think in this context, because you are reusing the show character, I think it makes sense to just have it as a global variable. Yeah, I'm inclined to follow your design choice. Anyway, so I think from there we can go to the specific test methods, and we have a few test methods here. We have should create new show character test, should edit character test, throw entity not found exemption. So the description here is test exemption handler handling entity not found thrown when character not found. Yeah, and a few more. So the test functions share some structure that maybe we can discuss before we look at the specialized way the test functions have been written. So the most common thing is this display name and test annotation. So maybe I can start with display name. So display name comes from JUnit. So JUnit is the testing framework that we use for Java applications. For some reason, it's like fully standardized. I don't know if anybody uses a different testing framework within the Java ecosystem. And JUnit, you'll see even some of the imports here, they are from org.junit. So JUnit provides us this test annotation, and this test annotation, when you add it to a function, it marks that function as a runnable test. So it allows you to, number one, be able to make that test discoverable to a test executor. So test executor could be the IDE, it could be Maven, like when we do Maven test, something I showed last time. So if we do like Maven test, when this Maven is running tests, it's able to discover some of these tests based on those annotations. Sometimes Maven uses the function postfix name, like when you name a function with and then end the function the function name with test, it uses that to discover the test. But using the test annotation also makes the test discoverable. So that's the first part of the test annotation. Maybe you can look at its Java doc to see whether you missed anything. A test is used to signal that the method that the annotated method is a test method. Of course, test methods must not be private or static and must not return a value. So they should be private for obvious reasons. They need to be discoverable by Maven or the IDE or in test executor that you're using. So about JUnit, so there is comprehensive documentation on JUnit and how it works. So there's a JUnit 5 documentation that pretty much covers everything you'd want to know about JUnit. So this is the doc. I always refer to this one, and basically has all the API and library function that you'd want to work with. So one of the things that's documented here is under writing tests. You'll see this display name section, and the display name section they talk about test classes and test methods can declare custom display names via a display name with spaces, special characters, and even emojis that will be displayed in test reports and by test runners and IDEs. So when you use display name, you actually make it possible for, these tests are executed in different contexts. So some of the tests are executed in CI. So it might be executed by a DevOps guy who probably didn't write the test themselves. So they're just dealing with deployment. So when there's a failure, they can actually see in their logs what's happening. So in that kind of environment, if you add this display name, the way you describe the test will be displayed during the test execution. So that allows one for somebody to know what's being tested for, and you can add in even additional messages to the person who's visualizing the test being executed. So like in the case, because David ended up using the display name annotation, if we execute these tests, so for instance, if we execute the tests in this controller, within the IDE, just scroll this, within the IDE you'll see what's printed is not the function names, but the description that we added in the display name. So for instance, the first test, test creation of a character with valid fields values, you'll see we have test creation of a character, we should have it here, test creation of a character with valid fields values. So you can have a bit more descriptive logs for when the tests are being executed. And that helps with the debugging, it helps with knowing what was broken when a test fails. So that's documented under display names. If you are working with different language, I think like Kotlin, they provide a different way to add those names. I think it's under test classes and methods, if I'm not wrong, where you can use a particular different syntax to pass in the names. Kotlin assertion support. This is a bit more detailed. It's a bit more robust than just display name, and unfortunately that's restricted to Kotlin. So JUnit JVita also comes with a few assertion methods that lend themselves well to being used in Kotlin. All JUnit Kotlin assertions are top level functions, and you can include them in the function name. So exception absence testing, you'll see something like grouped assertions, and those are actually processed as part of your test. So there's a bit more magic that happens there. But for display name, just know that it allows you to add descriptive names for your tests when they're being executed. I'll plug in the docs for JUnit. So if any of you get a need to like look at JUnit, you can find that in docs. Okay, so we looked at the first object, which is the MockMVC builders. So the second object within that doc is MockMVC request builders. So with these request builders, they allow you to actually perform the actual test. So if we look at one of the tests, I'll ignore this for now, I'll explain this later. But we just look at MockMVC. So first of all, when we are doing the, let me call it HTTP request, in this case, we use MockMVC to perform the actual HTTP request, signified by that perform function. So you see we are calling MockMVC request builders, and we are calling the post method. So these MockMVC request builders have different functions. There's already an import for them. No, there isn't one. So if we go to MockMVC request builders, you'll see that it supports those HTTP methods that we talked about. So you'll see there's a get, there's a post, there's a delete, there's a head, there's multipart, usually when you're uploading like files, there's patch, so delete, so all those requests are available. So you can use these to actually build the specific HTTP request. And they're called builders because you can, apart from just the request type, you can pass in other information like the content type that we talked about. So you can pass in media type application JSON. So if this was an XML based endpoint, you wanted to send out XML, you can pass in application XML as such. So you can also pass in the content, in this case the payload, the one we just created. So this will be JSON, if you remember when we converted it to JSON, and accept. So this will define, so when you're passing in the data, the endpoint should accept application JSON. So this allows you to kind of we are kind of acting as if we're in the client side of this request, and we are making the HTTP request to our API endpoint. So that's what you can do with MockMVC request builder. So you can construct the specific request, and you can see even with the other functions. You'll see here we are constructing a put request. You're passing the URI, request URL, then the content type. They're passing the content, which is the actual payload. You'll see here we're also calling object mapper, and then we are calling that edit character DTO into JSON, and that JSON is what we are sending out, and then we are defining the data type. Then you'll see that with all the requests. First you call MockMVC request builder, and then use that to build the request. So this is a get request, this is a post request, another post request, and they kind of follow the same format. So if you execute, for instance, this test, just look at the output. So you'll notice this will do a post, HTTP method post, and this is the URI it's hitting. Of course, the headers are what we specify, like content type, application JSON. You'll see accepts application JSON, and the content length is the size of the payload we are sending, and the payload is actually this request body, which has the character that we constructed. We'll go a bit more into the response, but let's go back to the method and look at it a bit more. So we've seen how this is converted into a sort of HTTP request, like you see here. Then when after you do the HTTP request, of course you need to do assertions to evaluate the response that you get from that HTTP request, and you can even evaluate the payload if the HTTP request returns some data. And you do this with the third object in the docs, that is the MockMVC result matchers. So within the MockMVC result matchers, you have access to a few methods. So you have access to JSON part, you have access to status, which status checks the HTTP status. So you have 200 for K, you have 403, you have 400, you have 301, and all the other HTTP response codes. You have stuff like forward URL. You have you have access to a few methods here, but the most commonly used one is the status and JSON path. Status is just used to check the status of the response, and the status can just be the usual status codes. Let's see if there's any Java doc here that probably talks about that. Oh yeah, so you can even see it in the functions. So use 1xx, so any error code within 100, you can evaluate it with that. Any error code within 200, so is 2 successful, is 3, which usually handles redirect. Common one here is 301. Then you have client error like bad request, 400, 401, you have 404, then you have the 500 internal server error code. So you can actually evaluate for your API endpoint returning any of these status codes just using the this status. I actually like doing static imports for this, but anyway, so you'll see after specializing into status, content and JSON path are complaining because they also come from that. So maybe I'll just edit this slightly, and then we have JSON path. So let's see how JSON path is being used. Oh, I think let's look at an example where status is being used. I don't know if yeah. So you'll see on the first function, and expect status dot is created, and expect status dot is okay, and expect status dot is not found. So if we run, for instance, the second MockMVC test, and now in this case we'll go down to the response. So you'll see it's doing a put request to this URI, and then this is the payload that's being sent in, and the server is responding with, so you find MockHTTP sublet response, the server is responding with status 200, and there is no error, and then the content type and the body. So the server also returns with this payload. So you'll see we are checking for status is okay, and is okay is within the 200 status codes. So I just check which one I executed. Editing character. I think that was the second one. Is okay. Is bad request. Yeah, so this is the one we executed. So you'll see it's evaluating. Is okay. And if you go into the docs, you'll find that it's okay actually looks for HTTP status okay, which is 200, which is generally successful. And this is specified. I think regardless of the framework, you'll be dealing with the same. Yeah. So if, for instance, we decided to evaluate for a different status code, like some of the ones we saw, like is client error. So maybe we expected this to do it's like a negative test. We want to ensure that it does a client error. You'll see that test number one, the test failed, and it's because the response is 200. So that allows you to evaluate the status codes that you're sending to the client. So that is status. The other thing there is content. So this allows you to evaluate the content that's part of the response. So you'll see content header there. Content type should be application JSON. So this particular test is evaluating for that. And then there's the content body that's that's part of the response, and that is what we use JSON path for. So JSON path is a bit of a more advanced concept. There's an XML equivalent. I think it's called XML path or something like that. XPath, yeah. And JSON path and XPath allow you to jump in between particular nodes in your JSON request or response and evaluate for data. So if you had a JSON like maybe okay, let's just use this as an example. So if we had this JSON response, we can actually go to description and check this value using JSON path. And the syntax you use is so there's a specification. There's multiple syntax that you can use. So $sign references the root of the JSON file. Then you can have there's use another syntax like dot dot, and then maybe you have something like a number like 4 or 1 or 0, and this is where you have a JSON array. So node with JSON array, so you can go to that node and obtain the first element, the second element, and such. So this is the main syntax that you use to access various aspects of the JSON file. You can actually go to a specific node by just using $sign and then the name of the node. So in this case, we're going to name here. So this is the particular section of the JSON response body. So when you do that, then we're able to access this Rick Smith, and you'll see this is evaluating the value to be Rick Smith. So you can actually expand these and test for something else, like you can say description is this boring version of Rick, and yeah, you can check that the value is boring version. So this will do assertion. It will check that this name contains Rick Smith. You can see actually contains Rick Smith. You can check that that description contains this description and actually contains that description. So that's what you can do with JSON path. There's some documentation on JSON path and what you can do with it, and there's some docs on XPath as well, and some of the functionality that you can actually handle with that. I don't know if it is documented outside Spring, but let me just see. JSON path docs. There are actually even online tools that you can use to do some of this evaluation. Let me just make sure that's called XPath. It's an expression language designed to support the query and transformation of XML documents. I think it's XPath. Oh yeah, David. You can let me just make sure. You can go ahead, David.
Just wanting to confirm what you are looking for. Yeah, there are some other cases, especially when you are trying to do what they call scraping. When you're doing web scraping, you find XPath a lot being used.
Oh yeah. These are really powerful tools because you can imagine the whole internet. It's either XML or JSON or object data. So if you can traverse XML data, I think XPath you can even use it for other things like you can evaluate HTML content. Oh yeah, Lennox, thanks for that doc. Let's see. Oh yeah, JSON path. So this is talking about. Let me just zoom in there. The document picks up the popular JSON path specification. Let me see if there's anything else. Okay, inspired by XPath. Frequently emphasized advantage of XML is the availability of plenty of tools to analyze, transform, and selectively extract data out of XML documents. XPath is one of these powerful tools. The need for something to solve the same class of problems for the emerging JSON community became apparent specifically for finding data interactively, specifying the relevant parts of the JSON data in a request by a client. So how does such a tool look like? Yeah, so you have array access, you have root object access, you have multiple this actually talks about some of the expressions we're using there. So you use this $sign to reference the root of the JSON file. The blocks are to reference nodes that have multiple values, like JSON arrays. The other aspects, they are nice. This is good. So we have the XPath equivalent of slash. Slash refers to the root of the XML file, and $sign refers to the root of the JSON file. You can use for JSON file. You can use this art or the current object element. You can use child operator, wildcard. So this is the one I was referring to for extracting values, where you have a JSON array. You can even do filtering. So it's pretty powerful, guys. So actually, so Lennox has shared the doc, so you guys can check it out. But yeah, you can use JSON path to evaluate. Which by the which means if your endpoint is receiving or processing XML, you can use XPath. I'm sure there's a Java library that provides those XPath expressions for you to use, and you can use us to evaluate your response. I've never tried this before, but let me just see. Oh yeah, there it is. So the result matches actually has XPath, and within there you can, within that you can basically do the specific evaluation stuff that you might need to do for your code. Okay, I just need to bring this back to JSON path. Still have some errors here. Yeah, so that's what we do with JSON path. Now let's look at the last section, last object that we use. I think it's the last one. And the last one is the MockMVC result handlers. So we've constructed the MockMVC, we've used it to perform requests, we've used MockMVC request builders to perform the request. We've used MockMVC result matchers to evaluate the response. And now we go to handling the response. So we've evaluated it now. Can we do a bit or more with it after that evaluation? So then comes the MockMVC request result handlers. So this, you can also import them statically. MockMVC result handlers. And one of the functions that's available here is print. Oh yeah, you can actually only do two things with it. You can print or log. So print I think it will use the standard output stream, sout, to basically print your whole HTTP request response cycle. So it will print the, it is something that we've already seen. So it will print the request, like we see here. So it will print the request as we see here, and then it will print the intermediary information, like which handler it ended up going to. The way we structure the URI tells MockMVC which endpoint to it, and there's a handler, there's a resolver within MockMVC that looks at the request URI and determines which class and function can actually handle that request. So you see the handler picked that up and it directed that request to the show character controller, and then show character controller.edit character. So this is the specific function. So if we go to show character controller, and if you look at that log edit show character, which receives a DTO and a string, I'll see edit show character, which receives a DTO and a string. So it's able to like redirect it here. Okay, so then so we've looked at the request handler. Remember that the result handler is the one that does the print function. You can do log, but print is also good. Just do it under the standard output string. And now when you run your tests, you'll be able to see. So you can actually also run them all together, and you're able to see the whole of the requests and like how they're being handled. So like this one does a post request to /API. This does a post request to /API /v1/character. A lot of people are joining when we are done. Okay, let me just admit and add the protections that we don't end up. Okay, so you can see this does a post request to /API /character /create, and then sends that particular payload, and these are the headers, and we get a 400, which is expected, and this is the response body. You can see the validators that we wrote are now kicking in, and part of the response is the error messages from those validators.